Hello, we're Team Takeo Comfort Solutions, and our project is the SmartPlug Bluetooth transmitter and receiver. Our technical directors who have been guiding us along the way are Phil Manning, an embedded controls engineer, along with Nick Costello, also an embedded controls engineer. Our team consists of myself, Andrew Crawford, along with Kevin Kwan and David Huang. Myself and Kevin are electrical engineers, and David is our computer engineer. Takeo Comfort Solutions is a 100-year-old, third-generation, family-owned global company based in Cranston, Rhode Island. Takeo manufactures high-efficiency indoor heating, cooling, and plumbing comfort systems. My team and I have been assigned to assist the company by improving the efficiency of one of their hot water recirculation products. Hot water recirculation is a process that uses a circulator pump which readies faucets and taps with instant hot water. Cold water in the pipes are pumped to the water heater, and circulator continuously circulates hot water through a plumbing system. In places like California, where there are water shortages, mandatory requirements are in place for on-demand hot water. This is because the average residents can waste up to 12,000 gallons of water per year waiting for running water to heat up. Takeo Comfort Solutions currently has a product called the SmartPlug that tells the circulator when to begin pumping hot water. A resident's water usage patterns are taken into account by the SmartPlug and put into an algorithm that determines appropriate times to begin hot water recirculation. This allows for 94% more energy efficiency by only providing hot water when it's needed. The goal of our project is to improve efficiency even further by adding manual activation with the push of a button. We are working on a physical button that will be placed next to or near sinks and showers, as well as a smartphone app that will communicate with the SmartPlug via Bluetooth. The physical button, as shown here, will use Bluetooth low energy as opposed to hardwiring a connection for the most convenience. This button we're looking to make battery operated, waterproof, and mountable anywhere with adhesive tape. Finding the appropriate Bluetooth processor was the first challenge our group encountered. We needed to find one powerful enough to communicate through walls, have up to 150 meters line of sight, and contain enough processing power to perform its functions. We decided to go with the NRF 52840 from Nordic Semiconductor, which is a 2.4 GHz long-range transceiver and processor. Some companies, such as Adafruit, have developed their own Bluetooth modules using this chip to allow for easy programming and testing. We decided to use Adafruit's NRF 52840 Express Feather because of its Arduino compatibility. Our best anticipated outcome is to have an improved SmartPlug with Bluetooth communication with the help of this module. The current SmartPlug PCB is to be modified so that it contains the NRF 52840 once we have the Bluetooth modules to properly communicate and perform their functionalities, as well as a smartphone compatibility. The economic impact of such a product would result in a $380,000 to $475,000 increase on-demand recirculation product sale annually for Takeo.
The first test that we conducted on the Adafruit NRF 52840 was creating a connection between a smartphone and the Bluetooth module. Using the Adafruit Bluefruit LE Connect app provided by Adafruit Industries, we were able to connect our smartphones to the Adafruit NRF 52840 over Bluetooth and send signals from the phone to the module. In the Arduino IDE serial monitor, you are able to see the different signals that were sent from the Bluefruit LE Connect app to the Bluetooth module. In order for Bluetooth to work between two devices, we must first assign the roles of central and peripheral to each Bluetooth device. The peripheral in the central and peripheral system advertises its device to a device set as the central. Once the connection has been made between the two devices, the central gives instructions to the peripheral while the peripheral waits to receive instructions from the central. For Takeo's SmartPlug and SmartButton, we assigned the SmartButton as the central and the SmartPlug as the peripheral. We attempted to simulate this setup by setting up one of the two Adafruit NRF 52840s as the central and the other as peripheral. To implement Nordic Semiconductor's NRF 52840 to the existing SmartPlug, we must redesign the SmartPlug's current schematics and PCB. We intend to use Altium along with Fritzing, an open source hardware initiative that allows the user to simulate circuit builds, to redesign the SmartPlug circuit and implement the NRF 52840 to replace the current processor on the SmartPlug. For the Smartbutton, we will also be using Altium and Fritzing to develop the schematics and PCB. The Smartbutton will utilize the NRF 52840 Bluetooth processor to interact with the SmartPlug and will be powered by a button coin cell battery, allowing us to reduce the size of the Smartbutton's enclosure.
For the firmware side of this project, most of our coding has been done on Arduino, making use of the Adafruit Bluefruit libraries. Beginning with a simple block diagram of our button, the button is in a sleep mode, waiting for a button press. Once it has received this, it will begin searching and checking for a Bluetooth signal. Once a signal has been found, a message will be transmitted to begin SmartPlug processes, and wait to receive a feedback message from the plug, finally looping back to a sleeping state. This snip of code is for the button to scan for and filter out the needed signal. For the scanner to properly filter out the correct signal, we are making use of a UUID, standing for Universal Unique Identifier. In this prototype, we are making use of one provided to us by our technical directors, though in the future we will be creating our own. Our firmware makes use of many callbacks. The ones currently shown are for that of the button, ones to begin the scanner, to connect and disconnect from a signal. The SmartPlug will also make use of similar callbacks to disconnect and connect. These are very helpful for debugging and troubleshooting issues, as they can provide a message for signals that were found and correctly filtered. Looking at the future of this project, we will be writing the firmware in C++, as well as updating it with any new functionalities we will be making. As for the hardware, the PCB of the SmartPlug will be redesigned to include a Bluetooth processor. The button will also have a PCB designed for it. Finally, we would all like to thank our technical directors, Phil Manning, Nick Costello, Mike Smith, and Capstone Director, Dr. Sunak, for their guidance on this project.